Okay, we move on to problem number 5. We have x to the third minus xy plus y squared equals 4. And again, I write out the problem taking the derivative of both sides with respect to x. Okay, so my derivative on the left side is going to be 3x squared. Now for the next term, I have negative xy. xy you have to look at as though it were a product, and it is a product. It's a product of x times some function of x that we call y. So we really have a product of x there. We have a product uh, of functions, and we're going to need to use the product rule for that. So the first thing that's very important here is because we're going to have a number of terms and there's a minus sign in front of that xy product, I really need to put a minus sign out there and put my my product, the derivative of the product, in parentheses so that I don't mess up the signs on it. Alright, so it's 1 d2, so it's x times the derivative of y, which is y prime, plus 2, which is y, d1, and the derivative of x is just 1, so the next term is just y plus y. And that is the derivative of xy. Now I always tell the AP students that this is a famous product when it comes to implicit differentiation. You will definitely see at least one case where you will have to find the derivative of xy. And the more we do it, the more you'll remember that it's xy prime plus y. Alright, now we still have to take the derivative of y squared, so that's 2y, y prime. And on the right side, because there's just a constant there, so that's going to be 0. Now again, in this case, in this case, different than the previous two problems, now we have two y primes that we're going to have to combine together and factor out and isolate in the end. Okay, so I'm still going to need to multiply out that negative to distribute the negative 1. And just remember those signs, they're such killers there. They can throw the whole problem off, so you really always have to be extra cautious and careful when you have negative signs in your problem. Alright, so what we need to do is combine together anything that has a y prime in it and move everything else over to the other side. Now when I do this, I usually try to take advantage of the signs that I have. I have 3x squared minus y that I need to move to the other side. So I'm going to move the y first, and it's going to become positive, and then the 3x squared is going to become negative. And I do that so that my first term is positive. Now with the y primes, I have a similar case. I have 2y y prime, which is positive, and negative x y prime. So what I'm going to do with that is write them so that I'm going to get a positive expression out of that. From this point, I want to factor out my y prime, and I get y prime times 2y minus x is equal to y minus 3x squared. Divide both sides by 2y minus x, and I'm done. Y prime is equal to y minus 3x squared over 2y minus x. Finished. And I'll go on to problem number 7. Okay, problem number 7 is a little bit different. I have a more complicated product in here, and I also don't have a constant on the right side. I have a variable over there. So let's get started. So I'm taking the derivative of both sides with respect to x. The first thing I need to do is take the derivative of x cubed y cubed, and that's going to be 1 d2 plus 2 d1. Let's see how that works. 1, the first function, is just x cubed. d2, the derivative of the second function, y cubed, is going to be 3y squared times y prime. So that's 1d2. Don't forget to do plus 2d1. The second function is y cubed. The derivative of the first function is just 3x squared. We still need the derivative of y, which is y prime, and the derivative of x is just 1. Okay, and the next line I just organize that a little bit. I have two y primes, so I need to get them together and move everything else over. And so I have 3x cubed y squared y prime minus y prime is equal to 1 minus 3x squared y cubed. Next I factor out the y prime. I divide both sides by 3x cubed y squared minus 1. And my final answer is y prime is equal to 1 minus 3x squared y cubed over 3x cubed y squared minus 1. Now it often is the case with these implicit things that you get these funny sort of reflections in the numerator and denominator just kind of twisted around. You can see how close they are to each other, but just opposites or whatever.